Can't hear you, Brian.
All right. Good morning. Welcome to today's webinar. I'm Brian Brocker from the Indiana University of Pennsylvania. And today we're going to talk about, our topic is, do you have combustible dust in your workplace? And a few preliminary items after I just went through them all while I was muted. Sorry about that, everybody. The first topic at hand that we want to discuss, preliminary before we get into everything, is in the bottom left-hand corner of your screen, there should be a microphone. If you can make sure yours are muted, that would be greatly appreciated. And this webinar is being recorded, so it will be available to you down the road. It'll be also available in PowerPoint presentation. Audio only available using your computer speakers. We'll answer questions, however, they won't be live. We'll get back to you because of the technical nature of the webinar. Any chat questions will be answered and posted on our website within 7 days after the webinar. So if you have any questions, please go ahead and ask them. We'll get back to you. Stick to the topic at hand. If you have any other questions unrelated to the topic, you can contact our office. On the first page is the phone number there. As we get into the topic, I'm assuming you're here because you have or believe you have combustible dust in your workplace and you want to know a little more about it. We may, it's a general review that we have. Again, if you have look at the bottom left-hand corner of your screen, there should be a mute button. If you can mute them, that'd be greatly appreciated.
I'm trying to watch this webinar and well, I don't have any sound.
We're getting some overfeed here.
I got my volume up. You can see it.
Anyway, you're viewing this today. Regarding combustible dust, we're going to talk about what combustible dust is and how an explosion occurs. We're going to talk about how to control or mitigate combustible dust hazards, and then what are OSHA inspection procedures and what may be cited if inspected. So it's a lot of information there, so we're going to hit the highlights of most of it. And some of it will be a little more detailed than others, but again, most of this is for highlights. Oops. What is combustible dust? What combustible dust are explosible? Metals such as aluminum, titanium, magnesium, wood dust, coal, and other carbon dust, plastic dust, biosolids, organic dust such as sugar, paper, soap, or dried blood even, and certain textile materials. When looking at the types of incidents out there, what types of dust are included? You look at food, wood, and metal take up about 2/3 of all the incidents that have occurred. The others are a lot smaller. Each of those close to 1/4 of it, so it's about almost 75% really. What types of industries have explosion hazards? You have agriculture, chemical, textile, forest and furniture products, metal processing, paper products, pharmaceuticals, recycling operations such as metal, paper, and plastic recycling operations. Industries where the incidents occur include, those are listed there on that screen, and you see that food products, lumber, chemical manufacturing, and primary metals, again, makes about 2/3 of all the incidences that are occurring out there. So that's where the OSHA's focus generally is. When we talk about combustible dust, to have a combustible dust, typically with fire, you have your triangle. With combustible dust, we are looking more of a pentagon. You have to have your ignition source, your oxygen or oxidizer, and a combustible dust, which is your fuel. So those three, plus in addition, you have to have confined, so it's being confined area. You have to have dispersion, something to rattle it or to get it into the air to make it ignitable. And then you can have your explosion. An initial primary explosion in a processing equipment or an area where fugitive dust has accumulated may shake loose more accumulated dust or damage a contaminated system, such as a duct, vessel, or collector. So basically, you have the initial explosion, it rattles, and then you have secondary, which will give you a demonstration here. The additional dust burst in the air may cause one or more secondary explosions, and that can be more destructive than your primary. So basically, you have a surface doesn't necessarily have to be flat. I have flat on there, but it could be a rough surface or even a vertical surface if the dust sticks to it. Something disperses it. It gets bumped, a beam gets bumped, a wind blows, something puts it into the air. There's an ignition source, and the cloud gets ignited. So basically, you have a dust collector. Oops, sorry about that. You have a dust collector. Fire occurs, an explosion inside the dust collector, and that's your initial explosion. And then what happens when it explodes? The building vibrates, the rafters vibrate, the dust in the rafters, it falls down. I'm talking with my hands, but and the dust is put into the air. So you have the fire going on inside your initial, and then after a while, explosion gets outside the initial containment, and all that dust in the air gets ignited, and we have a secondary deflagration. It gets worse, and through the dust clouds, it scatters through the entire building, and next thing you know, the whole building collapses. So that's where it can be much worse than the initial deflagration. How do we control this or mitigate it in some manner? Basically, it's through dust control, ignition source control, and damage control, which we'll spend some time going over some examples of these. Can't get into a whole lot of detail, but we'll be able to give you some ideas. NFPA 654 has a lot of good information that you can follow that help you comply with these regulations. You want to locate your relief valves. You want to locate the relief valves away from the dust hazard areas, and then you want to develop and implement a hazardous dust inspection, testing, housekeeping, and written control program. And it should establish frequencies of the testing and all these different elements. You have regular ongoing procedures. Also, NFPA 654, the guidance, some of the recommendations in there is to minimize the escape of dust from process equipment or ventilation systems, which is fugitive dust. Use dust collection systems and filters. Utilize surfaces that minimize dust accumulation. That's their focus. And you see a picture on the side there, all the dust, and as dust are not raindrops. At the earliest stage possible is where you want to start. If possible, in the design phase, you want to design equipment as needed and locate it where proper locations. You want to contain the combustible dust. You want to clean fugitive dust. You want to have a regular program for cleaning any dust. And you want to have access to hidden areas and safe cleaning methods when you do your housekeeping. And then maintenance, or refer to preventive maintenance, it should be throughout, to ensure that you're keeping the dust levels down. When dealing with dust, you want to wash down procedures with hoses and water where you can to move the dust. Nature, some of this, I know you can't do that, but if you can, wet methods are the best method to use when cleaning. You want to choke feeds to control the flow of grain in grain dust handling procedures. You want to use dust control systems with filters and cyclones where possible. We'll get into some of that. When looking at the dust in an area, in the grain industry, you look at an 8-inch dust is going to raise some flags. The rule of thumb generally everywhere else is 1/32 of an inch over 5% of the floor. 1/32 of an inch is about the size of a paper clip, so it's not that much. If you have a floor area of 20,000 square foot, then 1,000 square foot of dust in that area is going to be your upper limit, and it's going to put you into that 5% floor area. They look at bar joists and steel beams. The bar joists generally 5% of the floor area. The steel beam could be up to 10% of the floor area. So if they're covered, with 20,000 foot square area, then you could have an issue there. But it doesn't have to be 20,000, it have to be 10% of whatever floor area you have. For example, we might have an issue here. You see you have a motor, you have controls, are they explosion proof? Obviously there's enough dust, we get more than a 1/32 or even a 1/8 for the grain dust in that area. There's another picture, you have motors and control panels in there as well with dust everywhere. So we're going to look at ignition sources. There's a lot of ignition sources that can cause a problem. You have electrical equipment, static electricity control, mechanical sparks and friction, open flame control, design of heating systems, and heated surfaces as well. You have a lot of hot machinery out there, hot equipment. And use of tools and vehicles also can create your spark or ignition source. And then your maintenance as well. When you're doing maintenance, you're taking tools and things like that out there to do the work. So we'll get into detail of a few of these next. First of all, anytime you know you have to classify your area, and if you have Class 2, Division 1 and 2, that's your combustible dust areas, you have to have your electrical equipment designed with Class 1, Division 1 and or 2 in mind. You also have to consider you may have Class 1 or Class 3 issues in your environment as well that have to be considered. So you have to worry about that. You want to consider the equipment both inside dust handling equipment and outside, because you have fugitive emissions and things like that you have to worry about on the outside. Static electricity control is another issue. You want to make sure your grounding and bonding are the critical issues there. The inspection of grounding and bonding means that as vibration occurs, your bonding can disconnect. So you want to have a regular inspection program to make sure they're connected. Vibrating equipment systems may cause fatigue or failure in different straps. I think I mentioned that. Static electricity in the human body can also create your ignition source or spark. The human body can generate a charge of 5 kilovolts to 15 kilovolts during normal activity. The energy of a spark from a person can reach 20 to 30 millijoules. With that in mind, the minimum ignition energy for zirconium is only 5 millijoules. The aluminum is 10 millijoules, magnesium 20, and sugar is 30. So right there shows you the spark from our body, from static spark, can create ignition source. NFP 484 regarding combustible metals requires the following regarding static electricity. Static electricity of shoes for aluminum, niobium, and thallium are required. Non-sparking shoes for titanium or zirconium. No exposed metals on shoes for magnesium. So you need to evaluate the need for static electricity of shoes for any metals not specifically addressed in 484. For example, no exposed metals on shoes, a good place to start. And then you want to make sure the appropriate type depending on your operation. So you want to do some research on that depending on your products. Clothing requirements may vary, generally flame retardant, but may also require non-static generating for such things as aluminum and metals not specifically covered. Mechanical sparks and friction. So you could have rotating equipment from bearing failure can lead to very hot surfaces above your minimum ignition temperature. You have sliding surfaces creating a charge. Two metal parts rubbing together can create a definite charge. Steel tools dropping onto concrete or onto steel could create a spark. Preventive maintenance is a good mechanical regarding preventive maintenance, a good mechanical integrity management system or vibration analysis system is needed to detect problems advance with bearings and other surfaces. So PM is critical. Mechanical sparks, friction, open flame control. So anytime you have open flame, you want to control that open flame. Use of tools and vehicles. We mentioned tools, vehicles, fork trucks. You want to make sure they're rated, and I'll talk about that a little bit later. Again, the maintenance. All these areas, because you have hot work, basically requires a hot work permit system. Should utilize hot work when controlling these areas. So you have to lock it out, fire watches, etc. Ignition source control continued. Design of heat systems and heating surfaces. You want to know your materials. You want to know your minimum ignition temperature. So you want to research what you have, look at your SDSs, manufacturer's information. You want to maintain the temperatures and control within the limits stated. Moisture content can be critical. Sometimes if it's too moist, you have a problem. Other times if it's too dry, you lower your ignition temperature as well. During construction, during your design phase and everything, you want to use damage control. You want to have detachment where possible. Detachment means you want to put it outside or another building, or separate it from the rest of the areas. You can also use separation, put it in the opposite end of the room where people aren't working, put it in another room where people aren't working. That helps minimize the damage if something does occur. Put barriers up or segregate it from other areas, blast barriers and things like that, explosion barriers, prevent explosion from occurring from one to the other. Put things as less resistant walls on the outside wall so it blows outside. Of course, you have to look at the outside environment, what you have there as well. So if it's going to blow up a room, you don't want the inside wall blowing towards people. You also consider pressure resistance, pressure relieving, pressure venting, relief valves, and again, maintenance in all these areas. Detection systems, or as far as control systems, we have specialized detection systems, temperature, flame, smoke detectors, all that go in the detectors. You design it like in the picture on the bottom there. It's got a heat detector, so if certain temperatures down, it shuts down the system, or it sets off a specialized suppression system. It could be water, it could be foam, or whatever you need for your particular product. Then your explosion prevention systems, and of course, we all, once again, maintenance pops up, critical. I mentioned earlier a little bit about providing access to all hidden areas, permanent inspection. See in the picture there, you could have a drop ceiling or dead space where dust can accumulate, and that could be your explosion area. So you want to be able to have access to that so you can inspect it and clean it where possible. You want to look, again, we talked about the 1/32 inch. You want to look for areas that are hidden at regular intervals, and you want to clean where you can. Again, under NFPA 654, you want to use cleaning methods that do not generate dust clouds if ignition sources are present. Again, I mentioned where possible, you want to utilize wet methods. If you can't use wet methods, you want to use vacuum cleaners approved for dust collection, such as a Class 1 Division 1 Group EFG location. We want to make sure you're using proper rated vacuum systems. Again, where wet cleaning or vacuum is not possible, prevent dust clouds. So when you're cleaning in a manner that minimizes dust generation, so you've got a picture on the side there, you want to avoid that. Vigorous sweeping or blowing down with steam or compressed air produces dust cloud and should not be permitted. Only permitted sweeping only if following are met. The area and equipment are vacuumed prior to the blowdown. Electrical equipment and other sources of ignition shut down or removed from the area. Lock it out. That's the way to do it. The only low gauge pressure. They recommend or require 15 psi steam or compressed air to be used. So if it's 30, 80, whatever you want to do, knock it down to 15 psi. And you should have no hot surfaces capable of igniting dust or clouds. So if you have to let it cool down before you clean up, that's what you got to do. More on dust control. Reducing dust accumulation is a major concern for facilities that produce dust, obviously. So you want to have a good housekeeping program, an independent combination of methods to control the dust. We spoke a little bit about it already, housekeeping. The method used in any particular facility are dependent on the facility and the volume of combustible dust you're handling and the type of dust you're handling. So each site's dust control program and housekeeping program is going to be a little bit different than the next site. So it's got to be specific to your facility. Some general things out there that we want to talk about next. You want to have policies and practices and procedures designed to keep the conditions necessary for a fire coming together. We talked about the exploded Pentagon. We want to remove at least one or more of these 5 elements. You have your fuel, your dust. Is it dry? Is it at its minimum exposure concentration? You can remove the oxygen or oxidizers. Remove ignition sources, prevent it from being confined or in enclosed areas, and prevent it from mixing where possible. So you want to remove at least one of those, more the better. General policies you want to have in addition to everything we mentioned are you want to have hot work permits, as I mentioned a little bit before, lockout tagout policies. You want to follow specifications for storage of flammable materials, what requirements, industry requirements for that. Want to implement severity reduction policies, practice and procedures designed to minimize the spread of fire. You want to develop emergency plans, emergency response plans, emergency evacuation, etc. You want to install alarm systems and make sure people are aware of the alarm systems, practice the alarm systems. You want to provide portable fire extinguishers, ensure recharging those portable extinguishers as well. Provide first aid, ensure equipment and facilities are repaired regularly. That's our P&M. You want to have cleanup policies and practices, procedures designed to return the affected area to operational level if something does occur. And you want to remove any debris in the appropriate waste site. You don't want to pallet something else and create another problem. All this we were dealing with plant personnel, so we want to make sure our personnel are trained for hazardous environment. The training, you want to, specific topics related to combustible dust, you want to go over with them. You want to look at your SDS. Sometimes SDS are missing things, so you got to look a little bit further, like go to the manufacturer, tech sheets, things like that, to get more information. You want training on incident response, emergency response, emergency action plans. You want to have a pre-plan and a post-plan, and a during plan as well. You want to review and refresh on a periodic basis. As part of your training, you want people to recognize different hazards. You want to include them in conducting general facility-wide appraisals of dust explosion possibilities of periodic basis. You want to conduct internal and external audits in order to identify potential explosion hazards. You want to encourage a preventive attitude of employees for dust explosion. Get the employees involved, keep them involved, and interact with them. You want to have, when you do your JSAs or JHAs or whatever you might call them internally, written procedures, you want to supervise employees, make sure they identify dust explosion hazards. You want to pay attention to dust collection systems and other areas not in plain view during the assessment. Talk about the hidden areas and things like that. Not all of this stuff is just on the floor. As part of your program, you want to manage support systems, which is a key to successful combustible dust program, which covers your training efforts, your safety efforts, and you want to ensure regular cleanings of housekeeping issues. You're looking at engineering support, a lot of it to help prevent or mitigate combustible dust explosions. A lot of it's in the design phase. The earlier in the design phase, to get the engineering involved, get controlling the dust, the better. You look at hidden or access to hidden areas. You want dust-producing areas separated. You want or make them blast-proof, one or the other. You want to use intrinsically safe or explosion-proof devices at all times. Regarding engineering damage control, you want to evaluate the level of pressure resistance, relief and venting of dust in areas. You want pressure relief valve placement. Is it your valves in a place that's going to be more hazardous, or you want to move it to a place that's going to relieve into a safer environment? You want to have your action systems that are right for the application we have, and your extinguishing systems we're using the right methods. Operation support, again, we talked about good housekeeping, and you want to have a reporting system for malfunctioning equipment. You want to run that right away, and you want to eliminate any ignition sources where possible. More on the maintenance end of it. Regular inspections, talk about P&M the whole way through. You want to continue to have a good P&M program, and you want to have proper response to issues when they're noted. You want to document your equipment. You want to track your equipment, ensure that you're on schedule, and you want to make sure you're using approved parts and equipment for your application. It's back to more of the design or ordering phase there. You want to maintain documentation or everything to show that you're doing your due diligence and controlling your dust environment. You want to make sure you have a program review and employee participation in that review. You want to provide backup for everything and easy tool for all your information. That's all controlling the hazards. Let's talk about what would happen if OSHA comes in. Go over some things that OSHA would be looking at if they do come in. First thing, must determine the criteria must be met before defecation occur. We talked about some of the repeat. They're going to look at dust. Is it combustible? It has to be dispersed in the air or have another oxidant, and it reaches its MEC, or minimum exposable concentration. And it must be an ignition source. Talk about the Pentagon, the 5 Pentagon issues. He also showed that the combustible mixture is dispersed within a confined enclosure. And confined enclosure does not contain sufficient deflagration venting capacity to safely release the pressure, such as a vessel, storage bin, ductwork, room, or building. So you're setting up they're looking for your Pentagon when they come in. When determining whether a potential dust, deflagration, or a fire or explosion hazard exists, OSHA will look at your plant history. Look at your SDSs. As I mentioned, sometimes they don't have all the information they're supposed to when it comes to combustible dust. So they will do is they look at technical documents, look at spec sheets, things like that you have available on your products. Then the dust accumulations and note errors observed with dust accumulation. Again, they're looking at 1/32 paperclip depth and the square footage of the area covered. They'll also take samples. Accumulations are found, and they'll take samples in each area where they find it. And again, when they're looking at dust collection, they're looking at 1/3 the paperclip thickness. They're looking at structural members. Your bar joist beam or bar joist of 5% of your floor area, beams of 10%. They're going to do a calculation based on your square footage. Conduit, pipe racks, cable trays, and obviously the floor. Look at spaces above the ceiling. You have dead spaces. And they'll look on and around equipment. And they'll be looking in particular leaks around equipment or dust collection systems for failures. And they're going to take notes, samples of each of those areas. They're going to send everything to the lab. I'm not going to go a whole lot of detail into the lab, but some of the things they're looking at in the lab, they're looking at percent of the product goes to 40 mesh wire. They'll look at the moisture content, percent of moisture, look at the percent combustible material, and percent combustible dust. Metal dust, they'll include a resistivity aspect, because that's important in metal dust. And they'll look at minimum explosion concentration, minimum ignition energy. They'll do a class 2 test. They'll do some sample weighting, and they'll look at maximum normalized rate pressure rise, or your K value is what they often refer to, and minimum emission temperature. To put all these results together, determine if and how explosive your product is, and that'll determine your citation as well. When they're doing the walkthrough, they're going to look at all your containers and collectors anywhere dust is collected. And what they're looking for is a sound ignition control program. It prevents the introduction of ignition sources such as sparks, electrostatic discharge, open flames, and other similar sources. They're looking for housekeeping problems, which may be exasperated with inefficient operation of dust collectors. So if they're leaking or whatever, then the housekeeping will be more of an issue. Rule of thumb, dust collectors generally operate most effectively between limited pressure drops between 3 and 5 inches of water. So they're going to look at your manometers and things like that as well. They're going to look for your hot work system. Is it address hot work in and around collection points and dust work in areas where hazardous levels of dust accumulation occur? They're going to look at efforts to abate combustible dust. And they're looking at all the things we just discussed earlier, making sure you're following. That's why you want to document everything you have and be able to prove, hey, we're doing our due diligence and trying to get this stuff done. They're looking at exposure prevention mitigation controls. They're looking at isolation or segregation of dust generating processes. You know, is your dust collector in the middle of the room where employees are, or is it the opposite end of the room? Is it another room, or is it outside? It's going to go into their determination. Building damage, limiting construction. Look at venting. Is it vented in the right location? They'll look at process equipment reliefs, NFPA 68 has some information that they follow, and the NFPA 69 looks at isolation, explosion, suppressions. Again, I talked about they're looking at the dimension of the room, they're going to take measurements, and I'm going to measure how much of the dust is 1/32 inch depth. And again, with metals, we're going to look at the resistivity of that product as well. Design information on dust collection systems along with the model numbers, so that they're collecting all the information you have available. If you don't have it, they're going to go to the manufacturers. So get model numbers, serial numbers, usually from the equipment itself. And if you don't have the books and manuals, they'll contact the manufacturer and get it themselves. Again, some efforts on abating combustible dust. Dust collectors look at the size of the volume, and just a note in NFPA 654, they call them air material separators. That's your dust collectors. They'll look for warning signs or alerts on equipment referencing combustible dust, hot surfaces as well. Look at any source of ignition in the area, such as welding, fork truck traffic, etc. They look at information whether electrical equipment in the area is designed for use in the hazardous or the classified location. So the Class 1 division, when we talked about that earlier, make sure equipment is designed for that. They're done to collect all this information. If it's combustible or if they see issues, they may issue citations. I'll go through some of the citations that they do review. Number one we cite is housekeeping, 1910-22, 1A and 1A2. You have to keep states that you have to keep your place of employment clean, and your floors need to be maintained clean. So the dust on the floors and the dust around information systems is where they cite this. They have to substantiate their findings based on their samples, the amount, the measurements, everything else they collected while they were there to verify this. This standard is not cited in the coal handling within electrical power generation. That's on the next page. Then also look at housekeeping and storage areas, 1910-176C. They back up for these citations, they will use NFPA 654. They actually use all the NFPA, but this 654 is the common one with housekeeping. They'll also cite for 1910-307. That's your class 2 location, division that we talked about. As I mentioned, the class 3 and 1 locations may also be an issue, and they could cite that as well. And then I mentioned the electrical power generations under 1910-269-5, 11, Roman numeral 12. It's for cool handling, electrical power generation, transmission, distribution. That's that type of industry. That's where they're looking. And then also they look at state-specific standards as well. Today we're discovering the federal OSHA. The next area they cite is generally the general duty clause. That's 5A1. Here they specifically use the NFPA standards, and they use that as evidence of industry recognition. So they're showing that when they identify it in NFPA, that means you should be aware that for your industry, if you have an industry that's covered, and you look feasible and acceptable abatement methods that are addressed in that NFPA standard. In the standard, they have shalls, things that you shall do, and they'll use that as part of the standard requirements. And the shoulds are usually for other recommendations. So they'll stick to the shalls. If it's a shall, you better be doing it. More than general, they'll look at your employer manufacturing material, like I mentioned earlier, the safety manuals, owner's manuals, instructions, etc., which show your recognition. If you have that information, and most times you do, or it's available, that shows that you were familiar with the hazards. If you don't have it, then they use NFPA. Dust collectors, they'll look at the ductwork, equipment, location, grounding, venting locations, as I mentioned. They'll address that. Other important standards that could be cited: 1910-1200 hazard communication standard. If you're familiar with the other standards, silica standard, formaldehyde standard, specific standards, they all talk about 1910-1200 in their standard, and they show your training should be covered under the HAZCOM standard. So in your HAZCOM, you should address those issues, just like you should address combustible dust in your hazard communication standard. That is a hazard in the workplace that you want to train employees about and train them how to deal with those. So I'll look for that. Doesn't necessarily have to be in the HAZCOM standard. We should have something available. They'll cite you for failure to train. They'll cite you for inadequate safety data sheets. Either they're not available or the safety sheet doesn't cover the combustible dust. Then they'll also look at possible sources of employer knowledge. This is also used as a source of employer knowledge. We talked about the static charge. They cite you under 1910 132A, where you have to assess your workplace for the proper personal protective equipment. They'll be looking, do you have requirement for non-static clothing, flame retardant clothing, make sure you're dressing the right footwear in your assessments and your training as well. 1910-119 process safety standard. If you have a combustible dust that's listed in the Appendix A of the standard at the quantities listed, they'll use this standard in its entirety. They'll go through the entire process safety standard with you and cite 1910-119. Typically, citations of dust explosion not evaluating process hazard analysis and could affect covered processes. So if you didn't do your combustible dust in your analysis, you're going to get cited for that. And it may lead to additional citations with training or operational procedures. So if you have combustible dust and the PHA requires you to do additional training, they'll get you in all those areas. Some other ones, 1910-178, I think it might be C under power industrial trucks, talks about the classification, and there's in that standard you have combustible dust as one of the categories of classes you have to look at. You have to make sure your power industrial trucks are designed for operating in that combustible dust area if your area is classified. So you want to make sure your trucks are, when you buy your trucks, you want to make sure you follow that. 1910-252, welding, cutting, brazing. You have your hot work permits. You working in areas that have combustible dust, or you separating them from those areas. If you do have to weld in those areas, your hot work system covering everything it's supposed to cover. We talked about the 19-145C3 warning signs. You have warning signs of combustible dust in required areas. And 19-156, your fire brigades, or you'd follow 19-38 emergency action plans. If you're going to respond, they want to look at how you're responding. And if you're not responding properly, they'll cite you. If your evacuation procedures aren't up to par, covering combustible dust in its response, they'll cite you under 1910-38. 1910-263K2 covers combustible dust in a bakery equipment. So they'll address that if you're in a bakery. Sawmills are covered under 265C20I. They'll look at that as well. And then in the agriculture industry, they look at will cite you with HAZCOM and the general duty clause. So in summary, we discussed what a combustible dust is and how an explosion occurs. We discussed how to control and mitigate combustible dust. And we discussed what are OSHA inspection procedures and what may be cited if inspected. Some resources that you can go to, and I'm going to go through them here, but at the end on my references, I also list a bunch of links where you can link on to. But the NFPA regulation is important. I discussed the 465, 68, etc. The OSHA regulations, you want to look at the regulations I cited above. A lot of good resources out there with the OSHA fact sheets. And OSHA's National Emphasis Program has a lot of information. OSHA safety and health topics includes information, the whole section of combustible dust. OSHA hazard alerts and OSHA publications, and you do some searches in those for combustible dust, you'll find a lot. And again, my links, I have links for the combustible dust aspects at the end of my presentation. So in conclusion, with our little discussion about our program, the OSHA Consultation is a great service to the employers. It's often heard as the OSHA's best kept secret. Part of that is because we do not advertise a lot. OSHA does send out letters with their building national assist programs. They'll send out a letter stating they're focusing on your industry or based on incident rates. I'll send something out. A lot of times I'll reference us in there and we get some business that way, but the majority of our business is repeat business. And we get a lot of repeat business that tells a story that our customer wants us back. So it's a good service to offer, and we'll talk a little more about what we offer. The OSHA on-site consultation program is designed specifically for small and medium-sized businesses. What is a small business? That is 250 employees on site, which is decent-sized business, or 500 corporate-wide. So anything that size or smaller, that's our focus. We do prioritize based on the employees in high-hazard industries, which OSHA identifies those, National Access Program, and things like that. Or if you're involved in hazardous operations, those are how we set our priority. Large businesses can utilize our services, but it is based on a limited scope. So it's a specific area, specific task, specific program or OSHA area that we want to have respirators or something like that. That's we can cover that for large business. The good part news is we do not give citations or penalties. That's how we differ from OSHA. So, OSHA is going to give you a citation and a penalty for that. And it goes in your permanent record, and then you have to pay the fine, whereas we like to see use that money towards improving the elements of it, as opposed to paying a fine. However, there are obligations you must meet by utilizing our service. The employer must agree to correct any serious or imminent dangerous hazard. Typically give 60 days to correct hazards, and that varies on what we find, but that's a general rule of 60 days. If you fail to correct that and it's not beyond your control, it's under your control, we are required to refer that at some point to OSHA if you refuse to correct the hazards, which is very rare. I think since the program is in existence, we probably kind of want to end the number of referrals that we've actually had. Other benefits are the costs and savings. So we save you money through our costs because there isn't any. That's free of charge. Our time is free. We're a grant-funded program, so we don't charge anything. And if you have us in before OSHA, we can help you avoid OSHA penalties and mitigation costs. We also can help reduce workers' compensation by reducing accidents and injuries and illnesses. And we minimize equipment damage and product loss through our efforts as well. For example, typically one consultant can find as many, on average, of about 7 serious and other serious hazards, which could potentially save the employer up to $90,538 in fines per visit. So we could save a lot of money through our use of our services. If you're interested in our services or interested in finding out more about the topic discussed today, you can reach us at 800-382-1241. We're located in Indiana on 57 South 9th Street, Suite 305. You can also find us on the social media. You can see on our website is www.iup.edu PA-OSHA Consultation. You can also find us on Facebook and Twitter. And like I said, it'll take a week. This will be posted. Any questions will be answered as well. And PowerPoint will be available where you can review the whole webinar. And the next several pages do have a list of references that you can utilize as well. So I really thank you for your time and appreciate your patience to the beginning there. And thank you.